works on. Wait, gotta fix all my cables. So I haven't worked on this project for quite a while. I have 2 hours before I need to go to work, and let me explain what I'm doing. First of all, let me show you what I have so far. Hold on, my headphone cable is messed up. Okay. All right. So right now this code is half of it is disabled because I'm trying to debug, or I was trying to debug memory usage. So that number right here under the cursor is the memory being used. So you can do things like place wires, you can place, logic gates, connect everything together, etc. There's also an erase button, and so on. Now if you go into this menu, you can also change the simulation speed. There's an undo redo stack, which is currently disabled. And then you can save and load from, when I say disk here, what this is actually doing is it's saving to the map area of the cartridge. And finally, I have a copy area where you can copy some stuff and paste it using this guy, like that. Okay, now this does work and it's fine, but it uses a lot of memory. Let me show you what I mean. Let's take this guy for example. Each one of these guys uses a whole kilobyte, and we've only got a limited number of kilobytes, and I have a huge map that you can use. And I'd like it to be possible to fill the map. So what I did is I looked through my code and decided, not to mention, I mean, I guess you haven't seen this code here, but there's a lot of stuff in here that got really, really, really nasty. So for example, I'm trying to remember the keyboard shortcuts here. So this place junction function has tons of special cases. Everything has special cases, everything is ugly. But there are some things I do like about how this code was done. Oh yeah, this is a really bad one here. This erase square has a lot of special cases, and it's really bad. So what I did is I started doing this the other day. I copied this project to a new project called Experiment, and I started deleting everything I didn't want to keep. So I'm just going to redo everything from scratch except the things that I liked. That's my alarm. Okay. Guess I'm not completely awake yet, so anyway, yeah, we're going to delete everything that I don't plan to keep. Now I've already started doing this. Let me show you what I am going to keep. definitely I'm keeping all of these sprites that I drew. I'm actually really very pleased with them. I think they look good. I think they are effective, and the way that I've laid them out here in sprite memory is actually pretty good for saving and loading from the map. Notice here that in the map, so the way that the idea here, and this is an idea I'm going to keep, is that the state is encoded in the map, which lets you save and load super easily. Yeah. However, when you do a simulation, even though only a small fraction of the map is visible, you need to simulate everything in the design. And if you had to read back the design from the map on every single frame, it would be too slow. So one of the reasons why the code was so complex was because I needed to maintain redundant data structures. Yeah. Anyway, let me show you what else I'm keeping. So in this main one, I haven't really gone through here. Cursor position, that's fine, we can keep that. Viewport, we can keep that. Yeah, this stuff like the cursor modes, like the UI, I'm pretty happy with how it looked and how it was used, so I'm mostly going to keep that. Simulation speed, and yeah, this is fine, we can keep that. Speed index. Yeah, this is the function that gets, excuse me. That gets called inside that pause menu. I think this is fine. Hold on. 1 second. I'm trying to listen to music, but my headphone cable connected to my computer, I have an aux cable that plugs into my headphones, but it's totally wrecked. It's doing that thing where you have to hold it in the right position for it to work, so you need to get a new one. But what I'm going to do is just use my headphones instead. Or like use my phone instead. Okay. Now I can concentrate. Now. Oh yeah, and this updates the menu item so that it shows the right string. Yeah, okay. The undo stack, I think it's fine. The coroutine, so that we don't exceed the time of 1 frame, is also fine. We can keep that. These are fine mostly. That's fine. This is old. Can't remember. I think I had a better solution for this that I implemented manually. This is just, I don't know what to do about this right now. Well, yeah, we can keep this actually. Oh, this is just a little helper. what is fnum? If sim speed is not 0, then I'm not exactly sure what this is, but the UI stuff I mostly want to keep. I don't want to redo that. That's the most annoying part of writing this code. And it's mostly fine. It doesn't really get much cleaner than this anyway. Yeah, we can keep all this. Does this work? This is the deadline. We take the current time and give ourselves some fraction of a frame. I gotta open up the Pico 8 docs to remember the units on those numbers. Oh, okay, so 1.0 is 100% of a frame, so this is 10% of a frame. We allowed this coroutine to occupy up to 10% of the frame. The thing is, though, we need to because the state changes on every frame, so I'm not exactly sure how this is meant to work. Anyway, we'll deal with that later. Oh, there we go, yeah. So if the state updated, then we got to restart the snapshot. Where is this function defined? Start snapshot. Also, I think my version of Pico 8 is old. Well, anyway. So, updated. Where is that? If mode equals 3, then updated equals erase square. So how does this start snapshot work? Do you copy everything? We'll figure out point rotates later. Okay, so we put a bound on the stack's size. What does stat 0 do? Okay, yeah, this is the memory usage. Yeah, this is the thing, right? Like, because these tables can change on every frame. The states can change. With deep copy DL. Wow. Oh yeah, these notes, I guess I can keep these for now. I don't need to deal with that. Man, I thought it would be quick to get rid of the stuff I didn't want, but... Look up tile number given a binary state of cardinal directions used to draw wires based on neighboring connections or for drawing negators on gates. Seems like something I would want to keep. I think this is like, if you're not connected, if I do a bit mask of all the directions, I think that's how it worked. It tells me what offset to use. So 0 means I use that one, 1 means I use that one, 2, 3, 4. And then, yeah. Okay, we can keep that. I guess we can keep this stuff until such time as we don't need it anymore. I don't remember what this is. Also, I deleted this def meta table. Well, we'll cross that bridge. Gate value lookup table. Select format is negators. Oh, right. I have a script that generates these. Yeah, because this would have been really slow to do this. Alright, we can keep that too. We can keep that. Draw the grid. I mean, this is pretty good. I almost want to redo this as well. L, what is L? Linear coordinate. And O is the object in our, so this grid, this is our redundant data structure, which is meant to be faster than just accessing the map. I don't remember if this Pico 8 manual says how many cycles things use. Well, anyway. So if the object is a net, check the neighbors to determine what tile to draw. Yeah, this is the lookup value. For D in all neighbors, don't remember what the W means. This is the linear coordinate, and this is, I have no idea what. Okay, so, oh, weight, it's the weight. Yeah, you know what? We're gonna redo this, it's too ugly. My next solution is going to be similar to the original one because it was not bad. But I just really want to clean it up, that's all. I think that's okay. This draw helper stub, I guess we can keep it. That should be okay. Yeah, this I just totally deleted everything. So I could keep my same API functions that I had before, which was place wire, place component, and erase square. It's a perfectly fine API. So yeah, place component, place wire. But the whole reason I did this, well, there's two reasons I'm doing this. One is to just clean up the code because it was really messy, full of corner cases. The other one, which is arguably more important, is that I kept running out of memory before the user was able to fill the map. Now, what I don't understand, I'm just opening up my other one in text editor here, because I forget in place component how it figures out what component to place. Oh, it checks the G cell Y and X variables. I think it would be better if place component took the type as an argument. Now, before we start writing any code here, let's think about how this is going to look. I like the existing solution of what I'm doing with the map. this is tough. The problem is that tables are kind of expensive in memory. So I wonder if, without losing too much performance, what do I need? What do I need? I gotta write down what I need. Now, what do I have in here? Yo, that would be cool. Anyway, okay, so my sim loop for every driver. This is not true. I guess this is an old comment. Set driven nets state to high. If multiple drivers come to the same net, the net's value is the or of all the drivers. Then you draw the scene, taking care to highlight stuff properly. That's for selecting the copy region. Then compute next state for all the storage elements. Currently this is just gates, and they only have one cycle of storage. Where is that anyway? I think I called it like update state or something. Yeah. So I had two functions in the old one, update nets and update state. Update nets just asks the question, what value do all the nets have given the current state of all the drivers? And then update state we just update the state in place. Yeah, we don't need to save the next state. Oh, I see. Yeah, okay. So the map, like the tile numbers in the map, already have all the information, and we could use just the tile numbers to compute the next state. And the only reason not to do that is because it's slow. So what is the minimum we can do in our redundant information so that we can quickly compute the next state? Also, let me remind myself, oh, actually, I should share this on the screen, shouldn't I? So I have these gen lut scripts here. zoom in a little. And I wish I'd written down. Oh wait, no, I did write that down. It's written. Gate value lookup table. Select format is negators and the values of the 3 ports. So that means that we have, oh, I get it. So there are 3 inputs to each gate, and there are 16 kinds of gates. So 1, 2, 3, 4, 5, 6, 7, 8 by 1, 2. 8 entry lookup tables, right? 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So here, this gate has no negators. Oh no, wait. No, sorry. This gate has no negators. This gate has the negator at its output, I think, and so on. And for the reg, the select format is delay length. Oh, that's clever. The current state and the inputs. Now, inputs 2 and 4 are a latch control, or like an enable, and 3 is the D input. So each of these lines, I'm not sure what each of these lines represents. How long are you? So these guys, wait, no. We have 8, no, wait. We have 64 elements per delay length. I have 16 numbers per line. So these bottom 4 are for a delay length of just 1. So what's the output? The output is the next state. Oh, that's clever. The state for a delay length of 1 only has 1 bit, so I get it. So actually these 2, man, that's tricky. So these 2 lines are for a delay length of 1, and 2, 3, 4 for a delay length of 2, 2, 3, 4, 5, 6. Ooh. No, I think these bottom four. Wait. 1, 2, 3, 4, 5, 6, 7. No, we. Hmm. I guess it's just that these two are, or these three are unused, I think is how this is working. And then these two are unused, something like that. Like we'll never be able to get there because the stage should never be allowed to go that high. Alright, I'll be right back. Alright. Now, yeah. So where was I? Man, I remember why I got stuck on this now last time. So naive method. This didn't let you have the special character. guess not. Anyway, naive method. When computing next state, read tile numbers from map. But this is slow because, hold on, my music stopped. Okay. Because need to recompute. Well, there's a lot of reasons, like recompute net connection, or I guess connectivity every frame. Right. So we first start by driving all the nets. Oh yeah. The other big problem is this forces us to mset state on entire map. And I think mset is pretty slow. Let me just check that out. So it's 2 cycles to access an element of the table. Okay, and mset takes 3 arguments, which means, according to the calculation, is 2 plus number of arguments. So it's 5 cycles for an mset. And the map is huge. I think it's 128 by 64, is that right? Yeah. Yeah, it's 128 by 64. I think the second half of the map overlaps with the second half of the sprite table or something like that. I forget exactly how it works. Excuse me. So, in the worst case scenario, we would edit every single tile in the map. I mean, because we could always do optimizations like not editing the map if there was no change, but in the worst case scenario, we'll have to change every single tile in the map. So that's 128 times 64 times 5 cycles at minimum. Whoa, whoops. It's too big to be represented in the numbers, isn't it? Yeah. So that's 40k cycles. And how many cycles do we have per frame? Around 140k. That's actually kind of workable. Hold on. I want to try something. Let me just save this. What else do I have in here? I just need some random one that I can edit. I don't know. Ooh, what is this? I think this is my prototype for the nets. What the heck is going on here? Well, anyway, I don't want to lose that. I think I already have a... Yeah. So set, yeah, so function draw, okay. I doubt anyone's even watching this now or in the future, but this is going to flash on the screen here, so... Oh, maybe not. What is this even doing? Okay, what does that map function do again? So the map function, okay, stat 0. What is stat 0? Man, this is... Stat 0 is memory usage. So for I goes from 0 to 63, for J goes from 0 to 127. Just set some random data in the sprite table. And Whoops. So yeah, here we set every single so if I run this, so this is using 0.3. Does that make sense? So I calculated it would be 40K out of 140K cycles. So oh yeah, geez, look at that. 0.285. Yeah. It's slightly less than, yeah. So even if I update every single tile in the map, I still have about 100K cycles to play with. So but this is probably okay. I'll just write it as use about 30% of cycles. I'll just say use up to per frame to update state. Now, so this means that let's say, oh, but yeah, need to recompute net drivers on every frame. So when I go to update nets, I basically go to the first net, look at all of its drivers, and take the OR of all their values. Then when I go to update gates, I go to all of the gates and read the nets connected to their inputs. Now, one issue that I have is that junctions, unlike the other gates, are combinational. But the junctions are absolutely necessary. Okay, how much memory? Okay, what if I just do this? Oh, I see the problem. So apparently a completely blank project still uses 23 kilobytes. Don't ask me why. Can you call collect garbage manually? What time is it? Still have an hour, I guess. Okay, where was I? Okay, now let's just do. This is just a test to look at the memory and performance. Did I use a 2D map or a 1D map? I think I used a 1D map. Yeah, I did. We could do better than this, but this is just a test of like trying to give me an idea of how much performance I can expect if I do something like this. Well, actually, I really just care about the memory, so let's not worry about performance yet. Whatever. Okay, so this appears to take, we had 23 kilobytes before, is that right? This appears to take around 55 kilobytes. Now, does that match up with what the wiki says? Pico 8 has... Okay, we have 2 megabytes. Man, where did I see that? I think a table uses something like 2 bytes per entry or something like that. Man, where did I see that? Oh, it's right here. Okay. Table is 32 bytes plus 8 times the number of array entries plus 20 times the number of hash entries. So here, how many array entries do I have? I've got 128 times 64, which is 8K. Multiply that by 8 to give 64K. Oh, yeah. 88 minus 23 is 64-ish. Yeah, okay, so it's 64K if I just put numbers inside the grid. So 64K for the grid, up to 64K. No, always 64K. Man, I gotta think about this. So if every element of the grid table is we have 32 bytes, or bits, I mean 32 bits per number. Yeah. So yeah, we have 32 bits per number. And we only need up to 13 bits to select an index in the table, or an index in the grid. So every number in the grid can have 2 values in it. Okay, so maybe my original idea is actually still pretty good. We have a list of nets, gates, junctions, etc. And instead of putting pointers in the grid, which forces us to use tables inside the nets, grids, and junction lists. Nets, gates, and junctions list. Instead, we can use the upper couple bits of the number in the grid table to select whether it's a net, junction, gate, or other, or basically to indicate the type. And then the bottom bits to be an index into that table, which means that we can solve the problem of gates being represented as tables, because you can have up to 1 gate per, yeah, okay. Now we can do it even better, because we can save connectivity information as well in the grid. Because, so, okay, I think I finally am starting to realize what's going on here. Let me try and draw a picture. It's a little bit weird, but I just need a grid. Sure, this is... It's hard to find a good grid picture on the internet sometimes. Just whatever, I just need a grid. Okay, and go to the snipping tool. So when it comes to gates, gates live, you know, in the squares like this, and so do junctions. It's hard to draw with the mouse, don't get on my back. But nets live actually on the edges like this. Now the way that I've been doing this before is I don't maintain a second grid at this resolution. Instead, I'll say that there's a net inside one grid square, and then I infer which of the 4 directions is enabled by looking at the adjacent squares and seeing if the net is connected to it. But that's ugly. I think that was causing me a lot of the issues that I was having. I mean, the grid is 64K. I have lots of memory. If I'm not filling it with tables, like there are 8K entries in the grid. If I put a table in each of those 8K entries, then I'm going to run out of memory. That's the problem I'm having now. But if I put numbers, just numbers in those 8K entries, then I'm only using 64 kilobytes. So I can make that twice as big, 128 kilobytes. Who cares? I can have 10 of those, and I still won't come close to using up all the memory. So I can represent I can just have a separate connections grid, and I can still have net objects in the grid. So basically I have two superimposed grids. Which will be, like this. And then, so the red is the grid of connections and the black is the grid of visible, drawable components. So I can still have net objects, and I can still have gate objects. And then just decide how to draw them based on the connections grid. Yeah, and then each of these connections is going to save one number, which is the net number. And each of these objects needs to have a type and a number. Or does it? Because if I just have a list of objects, man, do I even need the black grid? I think I only need the red grid. I think we're finally making progress here. Okay, yeah, instead of this being an, here, this is just a wire, the visible wire. So we can have wires, we can have gates, we can have junctions, we can have redges, we can have visible wires. And you know what? This eliminates the need for junctions, doesn't it? Because we can infer what to draw based on which of these connections are equal, right? Perfectionist here. And the really cool thing here is that this black grid is encoded completely in the map. So when we go to update nets, we need to know the drivers. Well, we can skip all of the, because it just so happens that in my program, all the drivers are always on the right-hand side of a grid square. So we can skip any nets that are on a north or south edge of a square, and we can iterate through each of the east sides of a square. So we would iterate through, we would check what's here. I think this will work. I think this will work. So let's just delete some of this stuff here. Now that I think I finally found a solution to my problem here. I really want to finish it, but I've only got a half hour before I need to go to work. Well, that's life, I guess. Anyway, for each unique pair of map squares, AX, AY, there is a shared edge between them of adjacent map squares. Each of these shared edges has a associated net number. Sorry, I just have to answer a text message. Okay, so each of these edges has an associated net number that we store in the connection grid. Or I guess connectivity grid. So each pair of adjacent map squares, there is a shared edge between them. Each of these edges has an associated net number that we store in the connectivity grid. Okay. The rule is if so how do we go from an index to an edge? Well, the first row of indices will be the north edge of the first row of squares. The second row of indices will be the east edge. Well, okay, I think this idea is good. I really don't have time to implement it yet. I still have half an hour. Maybe I can get a proof of concept going. I wonder if this would be easier to just edit my existing one in place rather than take this hacked down version. Man, I'm gonna have a rough day at work. I'm already tired. I guess we should do this. How does this work again? think if you set something that isn't a table in the set meta table, no, actually, you do need to do this. So when we erase a square, so let's say we had something like this where we have some wires, some wires, some wires. Maybe we have a junction. Maybe something like this. And now let's say that, so I'm going to use different colors here to show the connections. So let's say that this is one net. And my apologies to anybody who's colorblind. Let's say that this is another net. Now, I currently don't think I want to allow the user to edit the... I basically just want the user to think of this as a grid. I don't want them to have to think about the shared edges between grid squares. In other words, I'm not letting them directly edit these shared edges. So one of the operations that I need to be able to support is what happens if the user erases something. So let's think about what happens if the user erases this square. Well, what I would need to do is first I would set the connectivity to -1 for all 4 edges to show that there's no connection there. But then the other thing I would need to do is split these 2 nets because they're no longer the same net anymore. So that means I need to do basically a DFS. So I would start at this edge, do a DFS to find everything connected to it, make that a new net, and then delete that. And it's the same as before. Likewise, if I were to delete this junction, I would do the exact same thing. I would do a DFS to just create new nets. Now here's a question. When I erase the last Actually, how am I doing that before? Like, am I just leaving gaps in the nets table? Oh, damn. Right. Because my original grid was a list of pointers, which meant that although the nets was an array, it was an array of tables, and if I deleted an element, it wouldn't change the address of the tables in the array, it would just change the order of them in the array. Or, I said that in a weird way, like, right, so I do need to worry about that now, where my net array, I can just delete arbitrary elements. I can just keep a free list though, like, that's not a big deal. Yeah, that's easy enough. We can keep a free list, whatever. Okay, so basically now I really just have one function, which is place object or place component or place grid object, whatever, and which is either a wire or a gate. And junctions need no special treatment, which is super nice, because junctions are now not separate from wires. Now, going back finally to this guy over here, I've solved this problem with this approach on the left. I still haven't solved that problem, so how will I do that? I guess in my list of gates, I can just save what net they're driving. So let me just start sketching some of this out here. I don't have time to work on it, so I'll just draft it out here. So for place component, we're going to have an x, y, and type, and this needs to well, it needs to update congrid. Update driver list. So instead of a list of gates, I'm going to have a list of drivers. Because what I would really like, okay, actually, you know what? Congrid. One, so saves net index for each grid edge. -1 means no net. Then net for each net index. Save what exactly? Now I want to just, I haven't said this out loud yet, but there are some invisible implied nets that the user would never know exist, which are if you have two gates back to back and they're connected, then there is actually a net that's not visible, it's not drawn, but it does connect like that. So that means that if each net is allowed to be a table, then we're back to the same problem of running out of memory, because in the worst case you could fill the grid with gates. You'd have an implied net. You'd have 64k implied nets. Sorry, you'd have 8k implied nets, each one occupying 32 bytes plus whatever's in the table, which is too big. I guess for each net we need its state. And actually one nice thing about this is that if in the future I want to have multi-bit nets, then it would just plug right in. Because the net states, well, you can infer the net states from the map. Hmm. I'm trying to decide whether I even want this nets table or not. Because isn't it enough to just keep net numbers? Well, no, because when I'm simulating the okay, when I'm simulating the gates, when I'm calculating the next state for each of the gates, I'm gonna check the state of all the nets that are inputs to it. So then I can do that by I know what coordinate I'm looking at since I'm scanning through the gates. And okay. So then gates edges, just a list of linear coordinates where they are found will just query the map for their past state. Or I guess I could just say their state. It's kind of slow, but querying the map. So setting the map, if we were to set every grid square of the map, it would take us 30% of our cycles. And if we were to query every square of the map, it would take us a little bit less, 4/5 of that roughly, so maybe 24%. So we can query the map once per grid square per frame, and that's okay. Yeah, okay. I'm just in my head trying to tally up all the costs to see if we're going to have performance issues. But we should be okay. What time is it? Oh, God. Man. Every time I work on this in the morning before work, it's always a. Because on the one hand, I would never have the motivation to work on this after a day of work. No matter how excited I am when I wake up in the morning after the work day is over, I'm just like, forget it, I don't want to do it. It just drains me. But now the problem is, I want to work on this, but I don't have time, which is kind of frustrating. And now I'm like more tired before my work day starts, which is going to make the work day harder to do. Man. I guess that's life. You know, we can have a really fancy lookup table, which just directly takes the tile number from the map as one of its inputs. Fine. I'll go to work.